expressed in the form of p by 0, that is rational numbers. For example, 7 by 2. If we the mixed fraction 18, we have to understand Pythagoras theorem. What is Pythagoras? At the point Q. And now in this time we are going to discuss about the class 9 Icse, Cbse and Ncert mathematics chapter rational numbers. Dear friends, hearty welcome to all of our channel Vibe with Surajit. This is now study time, and now in this time we are going to discuss about the class 9 Icse, Cbse and Ncert mathematics chapter rational numbers and irrational numbers, that is exercise 1.1, 1.2 and 1.3. In this chapter the main points are rational numbers, irrational numbers, and put some numbers on number lines, etc. I will discuss these matters one by one, and please keep watching. And I can say that after listening the full lesson and watching this video, I think there will be no confusion at all, and if there still be any confusion, then please feel free to write in our comment box about any of your confusion, and please keep the full video watching. So let's start. First, there is what is rational numbers. In our previous video we have discussed about the rational numbers. The rational numbers are those numbers which can be expressed in the form of p by q, while p and q both are integers and q not equal to 0. That is rational numbers. For example, 1 by 2, 3 by 4, 5 by 6, those are the rational numbers. We can say that the decimal expansion of rational numbers are non-terminating and repeating. So the numbers whose decimal expansions are non-terminating and repeating, these are rational numbers. And now we have to put some rational numbers on the number line. How can you do that? Suppose we have to put the number 3 on number line. How can you do that? First, let us draw the number line. A number line is that line where we can put numbers, any kind of numbers which we can put on the line, that is called number line. At the initial point is 0, and from 0 to right side it is denoted with plus sign. That is, if we move from 0 to right side, then the numbers will be counted as plus 1, plus 2, plus 3, plus 4, plus 5, etc. And if we move to the left side of 0, then the numbers will be counted as minus 1, minus 2, minus 3 and so on. Suppose you have to put the number 3 on the number line. How can you put that? We can easily find out the number 3 here. 3 means plus 3. Actually, if there is no sign at the left side opening number, we consider this number as positive. That is we consider the number as with plus sign. So here 3 can be considered as plus 3, and here we can easily find the number plus 3. Now after finding the number plus 3 on the number line, let us make this line a little bit longer or higher, and then write here p, and we can see that the number plus 3 is denoted at the point p on the number line. This is a very easy process. Now if we have to put the number 3.5 on the number line, then how can we do that? That is 7 by 2. If we turn the 7 by 2 in the mixed fraction, then it will be 3 and 1 by 2. Then how can we put this on the number line? Here we can easily find that the number is 3.5, that is equal to 3 plus half. This implies that the number 7 by 2 is bigger than 3 but lesser than 4. That means the number is a line between 3 and 4. 3 and 4, we should find out the particular position where it is lying. So first here is 3 and then let us reach at the point 3. Then here the denominator is 2. We have to divide this gap in two segments as the denominator is 2. So to divide this segment into two segments, here we can just draw only one line. And now look at this, the segment has been divided into two small segments, and this point is 3.5, that is 7/2. I think the conclusion is clear here. And again, suppose we have been given another number. Suppose we have been given 13/3. 13/3. To put, we have to put this number on the number line. How can we do that? Suppose 13/3. If we turn this number into mixed fraction, what will we get? We will get 4 and 1/3. This is clear that the number is bigger than 4 but lesser than 5. So this will lie between 4 and 5. It's clear. Let us draw the number line. Here is 0 as usual. We move on to the right side with plus sign. +1, +2, +3, +4, +5, and so on. And in the left side will be -1, -2, etc. It is clear that 4 and 1/3 we can write it as 4 + 1/3. It's clear that the number is bigger than 4 but lesser than 5. So this number, that 4/1/3, that is 13/3, will definitely lie between this segment, that is between 4 and 5. And we have to now find out the particular position where is this number lying. Here the denominator is 3. So we have to divide this segment into 3 small segments. To do that, we just only draw 2 lines. As we have to divide into 3 segments, we will just only draw 2 lines. Here we have drawn 2 lines and the segments have been divided into 3 smaller segments. And this is 4 and 1/2. This is 4 and 1/3. So this point is 4 and 1/3. So let us make this line a little bit longer and let us write there P, and we can write here that the number 4 and 1/3, that is 13/3, has been shown at the point P on the number line. This was the problem. I think it has been solved. How can I put any numbers on the number line? Another problems related to this chapter is we have to find out any 1 or 2 or more numbers between any two rational numbers. Then now we will consider about that. How can we do? Suppose we have to find out any one rational number between 3 and 4. How can you do? The easy process is average method. If we do with it average method, then 3 plus 4/2 is equal to 7/2 is equal to 3.5. Okay, so our rational number between 3 and 4 is 3.5. Now if we have to find out any 3 rational numbers between 1/4 and 1/5, then what will we do? Suppose we have to find out any 3 rational numbers between 1/4 and 1/5, then how will you do that? In this case, in this fraction, because these numbers are in fractional form, so we have to make the denominator same. How will you do that? Here 1/4 and 1/5. First, let us make the denominator same. In that case, we will multiply this by 5 and also this by 5, and to make the denominator same, we will multiply this by 4 and also the numerator by 4. Here we will get 5 by 20 and here we will get 4 by 20. But there is no exact integer between 4 and 5. So we can find any number between 1 by 4 and 1 by 5 here. So we have to move on the next step. What will be the next step? Next step is let us make it double. Then that is multiply both the denominator and the numerator by 2. What will we get? Here this will be turned to 40 and this will be 10. This will be 8. 4 to the 8 and 20 to the 40. Here between 8 and 2 we can get only one integer, that is 9. But we have to find out 3 numbers. Then let us double once again this number. If we multiply this by 2 and 2, what we will get? 20 by 80, and here we will get 16 by 80. Now there will be 3 integers between 16 and 20. Except 16 and 20, we can easily get 3 integers, and those will be 17, 18 and 19, and the numbers are 17 by 80, 18 by 80 and 19 by 80. So these are the 3 rational numbers between 1 by 4 and 1 by 5. Now we will going to discuss about putting some numbers on number line, and those numbers are irrational numbers. Suppose we have to put the number root 3 on the number line. How will it be possible and how can we do that? Before putting this number on number line, we have to understand Pythagoras theorem. What is Pythagoras theorem? Pythagoras theorem is that theorem by which this will be clear. Pythagoras theorem is applicable for a right angle triangle. Suppose ABC is a right angle triangle and where is B is the right angle. According to Pythagoras theorem, the square of hypotenuse is equal to sum of square of perpendicular and base. That is, AB is the perpendicular and BC is the base. According to Pythagoras theorem, that is AC square is equal to AB square plus BC square. And if we find out AC, then AC is equal to root over AB square plus BC square. This is the key features of Pythagoras theorem. Now we are going to put the number root 3 on number line. How will it be possible? So root 3 is equal to root over 2 plus 1, and now root 2 is equal to root 2 square and 1 is equal to 1 square. We have to put this on the number line. So let us draw the number line. Here is the number line. This is the point 0. Let us 1, 2. Now first we have to construct the number construct the number root 2 on the number line. So then we have to consider this segment of unit length, and also let us draw a perpendicular of unit length on the point P, and its name is Q. Here PQ is the perpendicular on OP and PQ is of unit length, and also OP is of unit length. Now if we connect or if we join the line OQ will be the hypotenuse, and according to Pythagoras theorem, OQ will be root over 1 square plus 1 square. That is root over 1 square is equal to 1 and 1 square is equal to 1. That is, this line is root 2. Now we will move on to put the number root 3 on the number line. What will be the process? Again, let us draw another perpendicular at the point Q and on at the point Q and of unit length. Suppose this is QR, a perpendicular at the point Q and on OQ. RQ is also of unit length. Now let us join the point OR. If we join this OR, so this is root 2, OQ is root 2, OQ is the base and RQ is the perpendicular and this angle is the right angle. So according to Pythagoras theorem, this will be OR will be root over root 2 square and 1 square. So this is equal to root 2 square is equal to 2 and 1 square is equal to 1. That is, OR is equal to root 3. But this is the line which is measuring root 3. Now we have to put root 3 on number line. Now we have to do what is, we have to take a pencil compass and we have to fix the pencil compass at the point O, and we have to take the radius of OR to draw an arc. So let us take the radius OR and draw an arc with a pencil compass, and we have to draw the arc till it touches the number line. Suppose this touches here and this point is suppose P1. So it is the number root 3. So here we have to write that the number root 3 has been shown at the point P1 on the number line. Again, if we have to put the number root 5 on the number line, then what we will do? Root 5, we have to put root 5 on the number line. Then what will be the process? Root 5. Now root 5 is equal to 4 plus 1, and now 4 is equal to 2 square and 1 is equal to 1 square. Like the previous number line, we will draw once again another number line, and here is the point O. This is 1 unit, this is 2 unit, 3. Now we have to take a point P where OP is the 2 units of length, and let us draw a perpendicular on OP. Suppose it is PQ. PQ is the perpendicular on OP, and PQ is of unit length and OP is of 2 units length. Now join OQ. Join OQ. According to Pythagoras theorem is applicable here because OPQ is a right angle triangle. So according to Pythagoras theorem, OQ is equal to root over 2 square plus 1 square, because OQ is the hypotenuse, is equal to root over 4. 2 square is equal to 4 and 1 square is equal to 1 is equal to root 5. But we have to put the number root 5 on number line. How can you do that? Similarly, we have to take a pencil compass and we have to take the radius OQ and we have to draw an arc centering O. Let us draw the arc. Still it touches the number line. Suppose the arc touches the number line at the point P1, and P1 is the number root 5. So we have to write that P1 is the number on the number line where we have shown the number root 5. Or in other words, root 5 has been shown on the number line at the point P. You can write this also.